Good day everyone. We are presenting our final project for operating system titled Crimson Reef Ascension. This is a 3D action game developed in Godot. Our project is not only focused on gameplay and visuals, but also integrating operating system concept into the design of the game. Specifically, our assigned CPU scheduling algorithms are round robin and highest response ratio next or HRRN. In this demo, we will show you the game's core gameplay, its UI and experience, and how these two scheduling algorithms are applied in the system and mechanics of the game.
The concept of our game is a room-based action-adventure where the player progresses through different areas, defeats enemies, survives hazards, and eventually reaches stronger encounters. The design follows a structured progression, so the player experiences training, active combat, and increasing difficulty. This room-by-room flow is important because it allows us to organize events and encounters in a way that matches scheduling logic. In operating systems, processes are managed, prioritized, and executed based on a scheduling rule. In our game, we translate that idea into enemy actions, encounter pacing, and threat management. Before we go deeper into the gameplay, we want to highlight the UI and UX design of the project. We designed the interface to be simple, readable, and appropriate for fast-paced gameplay. Important information like player health, progression, and interaction flow is visible enough for the player without overcrowding the screen. The controls are also straightforward. We use WASD for movement, E for interaction, space for dash, left click or L for the attack. This makes the game easy to understand while still allowing responsive combat. Our goal in the UI UX side was to make the player experience smooth and intuitive. Instead of making the player guess what to do, the game teaches movement, combat, and progression step by step.
Next is the gameplay flow. The core gameplay loop is based on room progression. The player enters an area, faces a challenge such as enemies or hazards, completes that challenge, and then advances to the next room. As the player progresses, the encounters become more demanding. Then, this structure is useful not just for level design, but also for showing how events can be managed like tasks or progresses in an operating system. Each encounter can be viewed as a unit of work that needs to be handled before the system moves to the next stage. In other words, the game is not just a random action. There is a system behind how threats appear and how the player responds and how the game escalates. Do enter a combat or training room. Fight normally, but don't rush too much. And clear at least one room if possible. And that's all for the gameplay flow. Thank you.
The first scheduling algorithm we applied is round robin. In operating system, round robin works by giving each process a fixed turn or time slice. After one process uses its turn, the CPU to move next one. This continues in rotation which helps maintain fairness among active processes. In our game, we represent the idea of round robin through the way active threats share the player attention across a fight. Instead, the only threat completely dominating the entire encounter, multiple enemies or action can pressure the player in turns or cycle. When several enemies are present, the player must react to different attack opportunities and movement patterns one after another. That creates a rotation of attention in a design sense. This reflects round robin because the threats are effectively taking turns influencing the gameplay rather than allowing one continuous dominant process. This is important because round robin is known to fairness. In the game, fairness appears as distributed action pressure. Different threats get opportunities to affect the encounter and the player must keep adapting. For example, in this encounter, different enemies are chasing, repositioning, or attacking at different moments. The player responds to one, then another, then another. That repeated cycle represents the round robin idea. Stay in a fight with multiple threats if possible. Move around them and don't instantly kill everything. Here, one enemy pressure me first, then another becomes active, then I shift again. This is our round robin representation.
Our second scheduling algorithm is highest response ratio next, or HRRN. In operating systems, HRRN selects the next process based on the response ratio, which depends on both waiting time and burst time. This means that a task has waited longer becomes more likely to be selected, preventing starvation. In our game, we apply that idea through threat, urgency, and decision making. A threat that is ignored for too long becomes more important for the player to address next. So the next target is not chosen only because it appeared first, but because its urgency grows over time. This matches the purpose of HRRN in OS. HRRN balances efficiency and fairness by helping delay process get solved. In our game, it appears when delayed or unsolved threats become the players' next priority because leaving them alone for too long creates more danger. For example, If the player focuses on only one enemy and ignores another threat, that ignored threat may become the more urgent one to handle next. The player naturally adjusts priorities based on waiting time and risk. That is the same decision principle behind HRRN. So while round robin is about prioritizing turns, HRRN is about choosing the next most disturbing or urgent process after considering how long it has been waiting. The next do first is during combat, ignore one threat briefly. Next then turn to it and say, this one became more urgent after being left alone, so it now becomes the next priority that reflects HRRN. If there if there is a strong enemy, range enemy, or hazard, use that as the example.
Beyond the scheduling concepts, the project also includes several complete game elements such as movement, combat, room progression, enemy variety, and scene transition. There's also effort to maintain visual consistency and a functional user interface that supports the theme of the game. Next, we will show the shop and a combat progression which demonstrate how the game becomes more structured and complete as the player advances.
To summarize, Crimson Reap Ascension is our final game project that combines gameplay design, UI and UX, and the operating system concepts. The game demonstrates room-based progressions, active combat, and structured encounter flow. Our first assigned algorithm, round robin, is represented through the rotating pressure and share action opportunities among multiple active threats. Our second assigned algorithm, HRRN, is represented through increasing urgency, where threats that have been left waiting become more important to address next. Through this project, we aim to show that CPU scheduling concept can be applied creatively in game systems, not just explained theoretically. That's all. Thank you.